Welcome back. Today we're going to be making a tool to finish our sword. So I need to clean up this fuller and I want to make a tool for this because I've been wanting this tool anyway. And that tool will be made from this round stock, and that is a small wheel. But it's not going to be a traditional small wheel. It's going to be one designed without bearings like these. So I want this to be sticking up in front of everything. That way I can run the sword across. And traditionally with these, it sets back a little too far that I would like. So what we're going to do is make a simple but hopefully effective small wheel. We will be cleaning the sides up, boring it, and then we will be 3D printing a shim to go in that's plastic. That way we have less friction between it and the bolt that we're going to be using to secure it. We're going to be using a bolt just for the fact that it'll go through the center and it will leave the whole front of this completely open to get into our fuller. So let's go ahead and get this started. One of the first things we're going to be doing is getting our material, and we're going to do the better end inside first. We can clean that up later, and we will also have to flip it around to clean this up. But we're just going to get it started in here, and I want it to go back just a little bit more. So we're going to do, we don't got a lot of room, we'll do 180 degrees on each of these. And this is just to eyeball it to get it hopefully somewhat close. So it's tightening up. We'll keep doing, we'll do 90. And once we do 90 on each, we should be getting fairly tight. And this is already tight in here, but the issue is it's not very symmetrical. So we have a tool for that. The tool is right here. This tool is called a dial indicator, and we are going to adjust this dial indicator here. Let me tighten that up, and we will move the dial indicator, adjust it to be centered, and we want to go closer to the end because that's going to give us a more accurate reading. And we can actually push this dial indicator into pre-tension it, which we will. So it's going to be roughly on 0 here. So how the dial indicator works is this can be exaggerated, but you will, if the surface is uneven, it will move the dial and it will let you know. So the farther up is the closer to you the material is. If it goes backwards, it is farther away. So we will go ahead and turn this to see where we are looking at. So right now we're on 0. So we can see that the farthest in we're about 45. So that lets us know this side here is closest to us. You go to the farther side, this one will be the farthest away. So we will go ahead and start adjusting it based on the dial indicator. Here is what a properly centered stock would look like. This stock, you do have to take in consideration, does have rust on it. So it's not going to be perfect, but we are roughly 2/1000ths of an inch difference between highest and lowest. So that is within acceptable, especially for this stock. So a big difference than we had before. This is a old mill that used to be ran on line shaft that was converted with a motor later. So there's a few things we need to do before we can start it. First is we need to loosen this up. This will put tension on our leather belt. We will go ahead and hit the speed controller, turn it on. We also have to do 2 more things. Here is a start, which it won't do anything until we hit our lever down here. we went ahead and switched this to a slower speed. And we are almost all the way through drilling. We have maybe another inch to go. I'm going to take this tool here, which is a boring bar, and we're going to take it through, and it's going to make sure that hole is nice and symmetrical. So we will be boring through it, and we will be boring a little over a 1/2 inch because the bolt we are using will be a 1/2 inch, and I want to have room for a 3D printed spacer for that. So there is the bored hole. We will clean the face off here. We'll go ahead and face it. And then we will clean up the rest of this rust to get everything down to the same finish, which a little bit of sandpaper on that, it smoothed it out more than enough than we need for this project. Now we are about to start the knurling. I marked off where I want it to stop. So let's go ahead and start this. We have the small wheel put on here. This is only a temporary one. I will be making a more permanent one with bearings later. But we got the small wheel on. It works. We're going to go ahead and clean up the fullers on our sword. We went ahead and got the profile marked on the sword. So we're going to go ahead and get that ground down. We'll have to clean up the fuller and make sure it is true to center. One of the things we need for the sword is a bigger quench tank. I've needed one for a long time. Here we have a 6-inch pipe. We are going to clean up the edges and weld it to some C-channel. And that should give us a nice sturdy base. So let's go ahead and get these cleaned up. We got all the paint off. We got the surfaces clean for both the C-channel and the pipe. We got it shimmed to make sure everything is nice and level with this. So we will go ahead and tack it and then run our bead around. We'll probably do a couple passes to make sure this is 100% liquid tight. We will be putting some water in to begin with just to test it because we don't want to waste any oil. So let's go ahead and get this tacked and then weld it up. That's it for this week's video. We got the sword rough profiled. We left a little bit of buffer room for after quench. We got the fullers cleaned up a little bit. There's still a little bit more that needs cleaned up, and we'll have to hand sand all of that, get it nice and even through the whole thing. So the sword is coming along nicely. we also need a quench tank for the sword since my quench tank before was way too small. So this is currently 54 inches. I'll probably cut it off at 45, but this will work extremely well. We did have to spend some time chasing some leaks on the welds, but so far it is dry and we've had water in it for over a day and there's no leaks, no moisture, nothing. So we are good. We are currently waiting for oil, and once we get the oil, we'll be able to quench this and move on. The only other thing I want to touch on before we end the video is this small wheel works surprisingly well. It is just a simple design, and if you don't have a lathe, you can also use a drill press to do it. But we did oil up the spacer that we printed, and it is a fairly tight fit. There's just a little bit of play in it, but it freely spins. We also 3D printed some other spacers, and it works extremely well. I will say this is not a permanent solution. This will just be something temporary to get through until I can go ahead and get some smaller bearings that I want to use to make a 1-inch contact wheel with bearings is going to be a lot better for the future. But that is all we have time for this week, so I hope you all enjoyed the video, and I'll see you in the next one.